TV. I'm Sean Kinney, and welcome to HetNet Happenings, where we take a look at all things DAS, small cell, Wi-Fi, and much more.
CommScope, thinking beyond today's technology to help you make the best decision for your network and your business. Telecom Careers, the #1 global telecom and wireless job board, telecomcareers.com.
Welcome back to HetNet Happenings. Our show this week is brought to you by our sponsor, CommScope. We're over at the Small Cell World Summit at the Excel Center here in East London. This annual conference is an opportunity for vendors and operators to get together to look at the latest in small cell products, as well as share information on growing trends in that developing market. In this first segment, we're going to hear from Kevin Duffy, who's the CEO and founder of Fastback Networks based in Texas. Their flagship products, the IVR, Intelligent Backhaul Radio. Kevin covers a lot of ground in this segment. What's of note are the backhaul challenges associated with small cell network rollouts that he touches on, as well as his prediction that a small cell deployment will cost underneath $20,000 American. That's of note, particularly when you consider the number of small cells that would need to be deployed to make for a robust network. Let's hear from Kevin.
You can simultaneously use all of the spectrum where it would be mission dependent, and among the 45 plus patents include that capability. So let's go back to the market and let's look at what would be a typical operator. Now, just using this as a nominal example of a typical mobile operator of medium to large size, they'll have existing macros, let's say tens of thousands of macros, in this case we use 40,000, and those macro sites will be of some vintage, 3G, 4G LTE, but let's assume they've upgraded to LTE, and they will be provisioned with some amount of adequate backhaul. Every operator in the world is going to want to start from there. They're going to start from where they already have a known position, and they're going to extend out. There's some people talking about doing UE relay from there. There's people talking about going from microwave down to the next location where the small cell is. But the point being is every one of those macros gets upgraded for LTE for data, upgraded for LTE, upgraded for LTE-A, and then you begin to use a separate spectrum, most likely, to underlay that with other devices. So start from there, reach the next one, and the next one, and the next one. Every device now wants Metro Ethernet. Backhaul is just, wireless backhaul is just over-the-air Metro Ethernet. When you say fiber, what you're really buying is Metro Ethernet that's derived out of a light pipe. If you're buying microwave radio, you're getting Metro Ethernet. Metro Ethernet comes with an SLA and a provisioning guarantee. That's what all of these will want. The problem is there's a physical gap that exists from where the Metro Ethernet to operate the cell is and where you want to put your small cell. So what we've provided is a company that says, regardless of where you want it, that's the freedom of location piece, put that where you want it. We can get you from your existing macro, or we can loop you back to any other provider in an urban setting that's likely within 500 meters to a kilometer. And there's probably more than one of them. So having a radio capability that says, don't think about it from here to here, think about it, put that where you need it, and there's multiple ones of these, and with the right combination of radios, you can actually foster and enforce competition on the optic side. Force the Ethernet providers to compete for that business. And the radio actually enables it. If you're going to take 40,000 macros, upgrade them, and a lot of those don't also have a problem having fiber to them. So getting backhaul to them that's adequate is also a problem to solve. But once you start to do hundreds of thousands of small cells, and I know I'm in Europe, so forgive me for quoting, I'll try to do it in both places. It's just that right now, recently in the US, Sprint's been very vocal about what they intend to do, and it's eminent that they're going to upgrade somewhere around 15 to 20,000 macros, and they're saying they're going to deploy somewhere between 50 to 100,000 small cells over the next 18 months to become the #1 network in the United States. So think about it, if you're going to do that, every one of those has to be thinking about deployability, scalability, and the performance of each individual site. And that's a Herculean task when you break that down. Someone's claiming they're going to do that over 18 months or 24 months. Well, take 100,000 divided by 24. You're talking about thousands per month, hundreds per day. That's an army of people. That's a lot of execution and precision. Each site can't be an individual planning exercise. It's got to be formulaic. It's got to be reduced to something that's repeatable and reliable and clearly affordable. So what would that look like? Well, the reality is it has to look like this. It has to. To deploy tens of thousands, tens of thousands of anything, it has to be sort of cookie cutter-ish, if you will. I think the industry, all of us in this room have been coming to these meetings for years now. I think collectively, I think we've done a good job. I think there's been advances across the world. Walking, Eric's has done great work with polls. The RAN community has done fantastic work miniaturizing the RAN. And I think Fastback and all of our colleagues in the backhaul community have demonstrated the art of the possible and shown that there are some real ways to do this. So if you say nominally someone's going to have a pole, have some varying height, all they really want on that pole, whatever flavor the pole is they want a RAN and they want a backhaul. They don't want a cell site router. They might want even AC power straight in. They want to have the power simple. They want to use the simplest, lowest cost labor they can get. They want to not have to have complicated, expensive, or sophisticated labor forces. They've got to be able to replicate that. The time to deploy, from the time you decide to stab this in the ground, erect it, commission it, turn it up, get the benefit out of it, is super important. The all-in cost of this, I believe, is trending towards sub 20,000 US, for sure, and obviously they'd love that to be much, much lower. They're going to want the flexibility to do any topology, means when you go from this one to the next one, or its relationship back to the macro, they're going to want to guarantee that they're not constrained by the topology. So backhaul and RAN can't be constrained. They're going to want to know that the RAN and the backhaul are simply looking at each other like two peers, two data networking peers. Fastback doesn't consider themselves a radio company. We consider ourselves a switch company, where one of the ports on our device is actually a really powerful radio. That's fundamental truth of the company. And so we look at it and say, if that's really looking for a Metro Ethernet socket, we provide that Metro Ethernet socket with a guaranteed SLA, and the other side of this is a radio port, but it's a switch port that gets back to the Metro Ethernet. Just that simple. Because you're dealing with a lot of variability in this path, it's undeterministic. Sometimes it's line of sight, sometimes it's line of sight. Sometimes it's far, short, sometimes you've got to go through trees, sometimes you bounce off buildings. I think there'll be people later today that'll talk about their experiences with some of those things. It's undeterministic, therefore your ability to take the uncertainty out is critical. If you're a backhaul provider, you've got to help them predict what the performance is going to be. You can't get out there and try to find out. So prediction tools become super important. Minimizing the number of managed elements, get it down to just two. The ability to put this pole where you need it, or to put these assets on anything that's not the pole, like I said earlier. Okay? And then obviously, anything that you put here and works with this has got to be fully integrated, fully interoperable, and fully compatible with everything. In the case of Fastback, we've integrated with everyone's core and proven to do so. So that's kind of what we've found out over deployability and the need for flexibility. So what I'd like to do is tell you, actually, at the end, we're going to open up for questions. This is who Fastback is. That's what we're about.
That was Kevin Duffy from Fastback Networks talking about some of the challenges and opportunities associated with small cell rollout. And on the topic of rollout, in this next segment, we're going to hear from Justin Paul. He's the head of OSS marketing for Amdocs. Amdocs is showcasing at the show their network rollout solution, which provides the project orchestration that a CSP needs in order to effectively minimize the CapEx and OpEx associated with the rollout of a small cell network. Let's hear from Justin Paul.
So the big challenge for service providers around small cells and HetNets is actually the economics of small cells are significantly different to those of the macro cells, the tower sites and the rooftop sites that they're used to rolling out. If you're rolling out a very expensive rooftop site or a macro site which requires civil works, significant engineering effort, if you have to go to site more than one time, in the grand scheme of things, it makes no difference to the economics of that site. If you look at a small cell or a HetNet, the cost of the equipment can easily be overtaken by the cost of the operational cost of visiting that site, because the costs are so very, very low. So what happens is you may pay $2,000 for a small cell itself. If you go to site 4 times, you've probably spent as much on the actual cost of rolling out that site as you have for the hardware. And that's a key thing for operators to understand. One of the things we try and do with the network rollout solution is to streamline and make more efficient the process of rolling out these networks, to avoid those additional visits to site, to avoid those additional costs. And actually that's the only way you can achieve the right business model for small cells.
All right, so we've talked about the physical side of small cell, and then we talked about the software side of small cell network orchestration. In this final segment, we're going to hear from Next Wireless. This is a Tier 3 carrier based in Kansas. And we're going to take a look at a use case. They had a stadium with a lot of coverage and capacity issues. We're going to go through why they selected small cell and how they managed to deploy and go live in just 75 days.
Network operations and engineering at Next Wireless. I'm responsible for end-to-end small cells, RAN, everything network. Kind of goes through my office. Next Wireless is a Tier 3 regional operator. So what I'm going to do is go through a little bit about who we are, and then a little bit about what our problem was and how we overcame it. Okay, how small cells conquered a stadium. When I hear the word conquer, it brings visions of Attila the Hun and things like that. We didn't quite do that, but we certainly overcame a customer issue. A little bit about where I'm from. A short 12-hour and 35-minute flight will get you from where we are now to where I live. You can see that's a pretty wide angle, so let's zoom in just a little bit here. So there's a little closer look at Kansas, Hays, Kansas, and Next Wireless, where I'm from. We need to zoom in just a little bit more to get a good look at my market. This is home for us. This is where we serve. We provide 3G and 4G services, 3G on CDMA, 4G on LTE, obviously. The landmass you see there is approximately the size of Portugal or South Korea. That's about how wide our network serves. So a little bit about Next Wireless, who we are and what we do. 339 cell sites, that's on the CDMA side. We serve 46 counties in Kansas and Colorado in the United States. Our total coverage area is about 36,920 square miles. Converted to English or standard, that's 95,000 square kilometers, or as I said, about the size of Portugal or South Korea. We have 60,000 subscribers. Our current push is to get from where we are with 3G to where we're going with 4G. So you can see of our 339 cell sites, 75 are currently 4G LTE enabled, and the rest will be by the end of the year. Another 132 will be, and then just continuing to do that in the next couple of years here. Competitors in our marketplace: Verizon Wireless, AT&T, and Viera Wireless, as well as another couple of regional operators. As a small Tier 3 operator in this space, it's very important that we remain flexible and that we over-provide on services. We garner about a 60% market share in the area that I showed you. That's 60% of the population, not 60% of the cell phones that are available. So we're winning. We're doing it by providing key customer service and providing a better experience to our customers than the big guys do in our areas. Now, it's important for us to partner with nationwide coverage. Obviously, those counties that we service, our customers travel outside of them. So we partner with Sprint, US Cellular, and the Competitive Carriers Association is an affiliated group of carriers our size in the United States that we roam on as well. Just a little bit about our network environment. Our CDMA network is Alcatel-Lucent. We have the items listed there, a 5E ECP. On the LTE side, we are an Ericsson shop. Currently, our cells are on release 14A, and we have the network elements listed there. A look at the problem child. This is the venue that we identified as needing to have a solution. The way that we were able to identify this is, unfortunately, the worst way that you want to hear about it. We had a large event take place in this venue. It was a wrestling tournament of all things. The stadium holds about 7,000, around 8,000, near 8,000 people. That's how many it can seat. Now, when we have these wrestling tournaments are a unique thing. People kind of fill the whole thing up. They're not necessarily just sitting in seats, and there's a lot of downtime. So what that causes is a lot of Netflix, a lot of Hulu, a lot of people watching TV on their smartphones. So we heard a lot of complaints. There was a lot of congestion on the network. Obviously, we saw a significant amount of blocking on our LTE macro that services the venue. So customer complaints were large. We identified that we had another event that we believed would be about the same size. We had a graduation coming up on March 15th. The wrestling event was on February 28th. So we had 75 days to fix it and get something in place and get customer experience better. A little bit about the venue. Obviously, it's 322,000 square feet. There's 3 unique coverage areas. I'll talk more about those later. And then there's also an attached administrative block building that we'll go through when we show the network diagram itself. A solution. This is what the solution had to do. So we were going to evaluate everything that was available to us, and it had to meet the demands of not only basketball season, when most of the seats were full, but wrestling, other high attendance events in the area. There are various fairs, certainly wrestling tournaments like we talked about, concerts, all sorts of things that go on in this venue. 6,000 to 7,000 attendees at most events, and here's the key I talked about a little bit. 60% of the people in our area are on our service. So of those 6,000 to 7,000 attendees, we can expect that 60% of those will have our phones, and of those, 70% will have our LTE smartphones. So certainly a high capacity, high need, intensive bandwidth for a short amount of time type of special event area. We needed the experience to be seamless. If a customer knows that they're on something that's not the regular network, we've failed. They need to have a seamless experience. They need to be able to do everything that they could do inside this building that they could do outside, and handover has to be seamless as well. Macro feature and performance parity. There are a few things that our macro does specific to multi-frequency band indicator and a few other things that had to be supported by whatever solution we chose. So those things are very important. Scalable capacity. I can't stress enough how important it is for a tier 3 operator to be scalable. I can't put in a solution and 3 years later have to replace it. The CapEx and OpEx just does not work. It has to be a long-term solution. It has to be something that can grow with us. Low cost. Obviously, cost is number one. Very important to us. We have to stay within a reasonable budget. Rapid deployment. Obviously, as I said before, we had 75 days from really evaluation, implementation, planning, and deployment to get to this next event. Here were the options that we had. There is an existing off-air DAS in this building that we've used to provide 3G voice services throughout the building. 2 problems with that. Obviously, a high-cost forklift upgrade. We would have had to completely replace the electronics to allow 4G to pass through this thing at the level that we wanted it to. The other problem is it taps off of an already overloaded macro cell. Anytime you use an off-air type solution to do this, you're stealing capacity from somewhere else. The cell that services this area is on a very busy college campus, so even in lieu of the events, there is still a lot of other capacity going on. Not a very good solution for us. Remote radio head solutions. So several of the large manufacturers like to think that you can take a base station and just distribute it through a facility like this. You can take and mount a remote radio head that you would normally mount on top of a tower somewhere within the building and just distribute the antenna throughout. This is a very difficult thing to get a building owner to let you do. It's a very large, very complicated, very difficult to install. So it's obviously space and licensing considerations made that one not a good answer for us. Standalone small cells came as kind of the other natural option that we could do. The difficulty with standalone small cells is backhaul, for one. You have to get backhaul to each and every area where you want to provide a small cell. The next difficulty is frequency planning. Areas where you can see two of the standalone small cells, your throughput suffers. So RF planning, the difficulty of installation made that not a starter for us. Airvana's one cell product is a cloud RAN solution, and it was the one that was eventually chosen through this selection process. The reason that it was chosen was ease of installation, low cost, and previous experience with Airvana. Airvana provides our 3G small cells, not only indoor but outdoor, and so we have a long-standing relationship with them that we were able to leverage to get a solution for this as well. Quick, just hit on this side quickly because we'll go through the deployment kind of in detail, but it needed to be a multi-carrier solution. We have both 1900 megahertz PCS and 700 megahertz. We operate our LTE in both spaces. Our PCS also operates in 1900 megahertz for our CDMA. So we had to do both. We had to take advantage of all of the capacity that we have available. Obviously, the more bandwidth we could deploy, the more we could serve our users. One thing that's important to point out here is backhaul. I mentioned that as a problem for deploying these standalone small cells. With the one cell system, we were able to provide backhaul to one area and then distribute it throughout the facility. This was key. We were able to partner with the university and partner with our existing service providers to get a large circuit in a very short amount of time. It was a fiber-fed circuit, obviously, and really was no issue. It was probably the easiest thing to get done. A closer look at the deployment. So the building stacks up into three different floors. The first floor is the Coliseum. It's the bottom level, it's the entry, it's where the running track is. Normally during basketball events and things like this is not a high capacity area. However, during our wrestling tournaments, a lot of our users are very sedentary, sitting in this area using high amounts of data. So it was an important area for us to cover. It's also where people come into and leave the building. So it's the area of handover. Very important to have strong coverage in this area. The second floor. There are stairs from the first floor to the second floor. The second floor is where the concession areas are, and it's also where a number of the VIP seating is. So it's a very important area for us. You can see we deploy three sets of RPs. You'll notice each time we deploy an RP inside the Coliseum, we deploy two, so that we can do the 1900 and the 700 both and provide the maximum amount of bandwidth for our customers. You can see the location of the controller. It has a single controller and then two power over Ethernet switches. The system is very easy to install. It just uses Cat5 Ethernet, and the one fiber junction that we talked about goes to that controller, and then it's spread through the RPs. The RPs are easy to install. I've heard throughout the conference people talking about Wi-Fi-like installation. This is more than Wi-Fi-like installation. It's Wi-Fi installation. Literally just installing an access point on a clip to a ceiling. Very simple. We were able to do the physical installation in 3 days. That includes cabling, installation of every radio point, start to finish. So here's where most of the seats are. The floor 3 is actually, these RPs are suspended from the roof. This covers the most of the seats. There are high rises on both sides, as you can see. So this is where most of the capacity and coverage is focused on, and you can see we deployed 4 sets of radio points for this area. All right. Cunningham Hall. So adjacent to the arena itself, there's a office building, administrative, there's a swimming pool in it, some locker rooms, racquetball courts, weight rooms. So in this area, we just deployed the 1900. This is more of a capacity play than a coverage play. There's not a lot of people in this area at any one given time, so we were able to deploy just the 1900 and serve them without any difficulty. Okay, here's a close look at the diagram so you can get a feel for how the system works. We have the radio controllers, and then you can see the fiber connections that go from one radio controller to the others, and then out from the controllers to the RP is simply just Cat5 Ethernet. all the way to the radio points. You can see on the diagram there where we've deployed 10 megahertz of 700. That's what we have available in the market that we launched this, and then 5 megahertz of 1900. The rest of our 1900 spectrum is used for voice and 3G data, so 700 is where we really have room to provide this capacity. Timeline. Again, I've mentioned a very compressed timeline. We had less than 75 days from conception, acceptance, to live event time. So what we did was we took laboratory and field testing, we brought a one cell into our office. We were able to serve our office building and our laboratory off of it, just to get a feel for it, just to make sure that it did what we wanted it to do, that it met our expectations and would serve our customers well. Once that field validation was done, we began the arduous process in late April of trying to get this installed, commissioned, and brought on air before that May 15th graduation date. As you can see, we were successful. There were really no roadblocks along the way. We were able to very easily get the physical installation done, and installation and tuning went very well, and the graduation, the live use happened really without a hitch. Conclusion. It was a resounding success. Nextech Wireless and Airvana were able to deliver a superior customer experience. We remember at the beginning, one of our goals was timeline and customer experience. You never know until your customers tell you whether or not you missed the mark. And certainly in previous events, we had a lot of customer complaints and had missed the mark in a very big way. Compared to this event, we received no customer complaints. Obviously, we seeded the market. We had several of our engineers kind of seeded throughout the graduation, doing speed tests, probably more than they should. As engineers, we like to speed test. We like to make sure that things are going as fast as they can. And we're able to get 50 meg down throughout most of the event. So it was very successful for us. Excellent throughput during the event. And again, I want to stress that this was conceived, executed, and deployed in less than 90 days. So our conclusion is that the one cell met our objectives, both time to market and customer experience. Now, for us, the next question is, where do we go from here? What are we going to do with it now? A lot of areas that line up with this stadium and have some of the similar problems are hospitals, large enterprise customers, certainly any area that we cannot, with the macro, provide either coverage or capacity to an indoor area. This solution certainly bears out. It's something that it's a tool that we needed for our toolbox, and it helps us be flexible and provide the best possible service to our customers. Compared to our DAS solution, when we looked at upgrading the DAS solution in this building and price that out and look at the full forklift upgrade, the one cell was about half that cost. So it's very cost effective and something that really is a great tool for us. It's something that we have to remain flexible and to remain competitive against those tier 1 competitors in our market.
That was Nathan Sutter of Nextech Wireless. We've tried to give you a sort of end-to-end look at the HetNet ecosystem that's being displayed here at Small Cells World Summit. For a lot more coverage of this event, you can check out the RCR Wireless News website, as well for multimedia coverage, the RCR Wireless News YouTube channel. I'd like to thank you for joining me this week on HetNet Happenings. I'd like to thank my sponsor, CommScope, and we'll see you next week.
HetNet Happenings is a production of RCR TV. To reach Sean Kinney or to suggest a show topic for HetNet Happenings, you can reach Sean at skinney@rcrwireless.com. On Twitter at SeanKinneyRCR. To find out more about the latest in HetNet and all things wireless, dig into rcrwireless.com.